Okay, press the key to start. Okay. Keyboard to mouse, I believe, is how you... After receiving my A500 Mini from Amazon, link in the description, there was one thing I really thought was missing. It really does make sense why the keyboard is non-functional. The scale is not conducive to any real usefulness. I still thought it would be a cool project to create a working keyboard for the A500 Mini. At the very least, I can always learn from these types of projects. The truth is, I never had very high expectations for this build once I opened up the case and looked at the clearances. Unfortunately, I lost the footage of opening up the case and examining the keyboard, but here is a pretty good representation of the key assembly that I made as part of the design process. The injection molded key assembly is actually 3 parts, separated by color. Unlike the outer case, the key assemblies are painted. The underlying color of the plastic is black, as you will see later. The base of this assembly is a scant 1.6 millimeters thick. There is not enough room for any type of plunger or otherwise ergonomic key switches, at least not if I wanted to keep the case looking normal from the outside, and having minimal modifications on the inside. So that means I need to use micro switches. There was a bit of room in the upper part of the case, so I looked online for the smallest keyboard controller I could find. I thought about taking the time and effort to make my own controller, but I quickly found a small controller designed just for this kind of DIY project. The 104 key version should suffice for the A500's 94 keys. It comes with a goofy key matrix which I will undoubtedly replace with my own custom one for the A500 Mini. The dimensions of the controller board are not listed, but fortunately someone answered my question on the subject. Wait, 152 millimeters? That's the keyboard matrix, not the controller board. It's probably because I misspelled please, right? Using the pictures as a reference, I compared the dimensions given, and it seemed small enough. I plan to remove the USB port, which will save a lot of room. So I rolled the dice and ordered it. Here's to hoping this picture was taken in perspective. While I wait for the controller board to come in, I went in search of the right micro switches. I bought a ton of them. If you know anything about prototyping, you can look at the datasheet for dimensions all you want, but you will never know for sure until you have one in hand. The 2 types of micro switches that would work are snap dome and button type. The only other way in such a thin application was to use a custom membrane, but that would either take longer to design, be more expensive, or both. Regardless, once I had received my plethora of switches, I decided to use this button switch, which seemed to have the right balance of tactile feel and ease of installing on a PCB. I then received my keyboard controller kit and made sure it worked with the A500 Mini. It seemed to work fine, so then I had to go about reverse engineering the matrix so I could replicate it with the needed modifications for the A500. Of great help was the fact that the back side of the matrix was labeled with the keys, and also with what seemed to be numbered row and column designations on the connector. Then it was simply the tedious task of creating a schematic with all the information gathered. I decided to lay the schematic out roughly the way the keyboard is laid out to help in revising and troubleshooting mistakes I may make. By the way, I do not know who designed that keyboard matrix that came with the kit, but they certainly do not suffer from OCD. Look at how these row and column paths jump around. If it was me, this schematic would have traces that look like a grid rather than a rat's nest. Perhaps it would look better if this was a Chinese language keyboard matrix. Pretty likely this was designed and produced in China. So then it is the equally tedious task of creating a PCB layout. This is what happens when you convert the schematic to a PCB. You still have to do all the placement and labeling work, but at least all the components are here. It starts with the dimensions of the PCB. I'm going to replicate the original keyboard base for the A500 Mini, including this cutout. After many hours and 4 revisions, here is our final product. And you can see more of the rat's nest as I highlight signal paths. Not ideal. And here you can see I built in a caps lock LED, the wire connections for which are located on the back of the PCB in a convenient spot. I have a lot of experience modding projects for LEDs, and at this stage I have a rough idea of how I will be showing it on the actual caps lock key. So we have a PCB figured out and the components sorted. So what am I going to do about actual keys on the keyboard? I thought of 3D printing keycaps, but really I already have some on the A500 Mini. The path of least resistance would clearly be to cut these out and use them. That decided, I know I can't just glue them on top of the micro switches. With such a small contact point on the top, that would never last. I came up with the idea of making a flexible support membrane to glue the keycaps to. I can do this with my 3D printer using TPU filament. I rarely use this flexible filament as the parts I usually print need to be rigid, but I'll be damned if this wasn't a good use of it. For those unfamiliar with the major drawback of using TPU, it is hygroscopic. It absorbs moisture from the air. I live in a moderately humid area, which means my prints come out stringy, unless I keep the filament dry or use a dehydrator on it. As it turns out, this is not really an issue because remember, this will be a substrate for the keys rather than a visible part. I will just have to yank off the stringy bits. I just need to be able to glue the keycaps to it, and I see that there is a cavity under each key. I will design a membrane that has nubs to go into those cavities, and I will make them slightly smaller to give myself some wiggle room, literally, in order to tweak the alignment and position of the keycaps. I will also create a very thin spacer out of regular ABS plastic to go between the PCB and the membrane, to lift the membrane off the PCB and help mitigate accidental key presses. Okay, so I got a system down. Actually, when you keep doing this, you got to do this 96 times or whatever it is. And, you know, basically I can cut just enough with enough experience doing a dozen of them or so by now. Cutting just enough to make it super loose and pretty much where I need it. And then the thing kind of basically just pulls off. And then from there, I can just finish it off with rubbing on the sandpaper. And this way it only takes me 1 to 2 minutes to do each one, whereas the first few, you know, is up to like 5 minutes a key or something ridiculous like that. Still have to cut out the part that got melted on the inside. You got to cut it out good because it will hang up on the TPU posts. And also, I didn't, I probably am going to mention this before, but I didn't properly have my TPU dry when I started printing it. And these posts are kind of ugly, but you know what? For the purposes of this, they actually kind of work. So. As I said, I had 4 iterations of the PCB. I had issues like needing to change the microswitch pad placements, ribbon connector pore placement, and of course the addition of the caps lock LED. Okay, so this is the latest version, version 0.4. Okay. So obviously we went through 4 versions of this. It didn't take too long to get it correct. And a couple things I did is I shrunk down the labels here so that they would fit in the corner instead of having them spread out over this area. And a very disappointing thing I did was I took the caps lock LED on the version 0.3 and I put it underneath this, where this switch needs to go here for the caps lock, which was really dumb. I don't know why I did that. So here it is off to the side, and hopefully a LED will fit there. It's a standard 1206 LED, and hopefully the switch and the LED can coexist. In fact, that's probably the first thing I'm gonna try. So the switches that I'm using for this are from DigiKey. They're made by Mitsumi. This is probably the Mitsumi part number here, R-667843. Or maybe that's, I mean, that does seem to match the others. Okay, anyway, so that's what I designed this circuit board with. It's, you know, they're just a couple millimeters. I think it's 4, including the contacts, it's 4, you know, width-wise, and like something close to 3 height. But then you take the switches and you mount them at 90-degree orientation so that the longer length with the contacts is up and down on the top and the bottom. As you can see, you can kind of tell that these aren't exactly square, you know, because of where the contacts are. This switch is taller than it is wide. You can see the white line delineates the edge of the switch, or just outside the edge of the switch technically. So, a couple of decisions I made which seem to have panned out pretty well is the fact that on the larger keys, such as spacebar, shift, enter, I decided to put more than one switch, so that if you push on one side or one edge, closer to one edge of the key, it's still going to register a key press. If I, for example, put the space bar and I only had a micro switch in the middle, when you pushed over here on the edge, it probably wouldn't register. So I did it on the space bar with 3, and then the others such as shift and enter, I did 2. And then there's the enter key on the numpad, I did 2 as well. So basically, As with most SMD assembly, you want to use flux. It has two purposes actually. You'd think it would only have one where it lets the solder flow, but it actually will hold your part in place. So every single one of these I'm gonna use with some extra Chip Quick SMD 291. SMD 291. Obviously tweezers are a requirement here. Looks like our components are going to fit next to each other. Let's get the LED out. So the LED, did I not put the polarity on the board? Covered up with flux and I can't see it now. Okay, so the top one's on the top and it says negative. So negative is on top. The bottom one goes to a via that's on the bottom and that says positive. So, okay, so the green side with the little cutout is negative, cathode, and anode is over on that side. Alright, we have our soldering iron set to a logical SMD heat, 350. There we go. So I'm actually using a tip that is too big normally for this application. Because these switches are, a little more bulky and larger, it's helping me to take the wedge, the flat part of this, and go up against the switch. So getting a little solder on the tip first and then going like this seems to be helping me. So that's a common there. So I'm just going to test to make sure my polarity is right and that I have a good connection. Piece of solder there. Let's see. So I'm going to have to, yeah. Alright, so I'm just going on the back of the board and I'm just going to go like this and light it up. And there you go. Alright, so yeah, so we have a nice set of pads here for soldering a wire to, and we're going to use some really thin wire. I recommend it at the very largest 30 gauge or something smaller. A lot of people have 24, 22, 26. That'll probably interfere with the fitment of this board. And it's always a good idea if you work on stuff like this to have 28 gauge or 30 gauge. Anyway, I'm going to get to work installing the rest of these on here. So that doesn't look perfect to you, right? Doesn't look perfect to me either, but you know what? I got a lot of these to do. I'm getting sick and tired of this job, and they're gonna work and they're gonna be hidden, and as long as I make sure that we don't short against the top plate and that we don't have solder like sticking up past the button or the assembly or whatever, then I think we're good to go. The flux is actually flowing everywhere, even inside the switch. One thing I did learn on the last revision of the board is that it does affect the ability for the switch to recognize a keystroke. So I found a good way. I mean, I used my normal technique actually of spraying it off with alcohol, but when I do it on this one, I put the board vertically, squirt it, just keep squirting it, and then use compressed air to kind of get what's in there to come out, and then do it again. Do it like 3 times, and it really fixed the connection issue that I was having. So. And now for the most important part, the part that a lot of people forget or skip over, to do a close visual inspection with some magnification to make sure that it looks good. And now for the 26-pin connector. Now the first time I did this, I didn't get it quite right. Basically what we want it to do is we want it to lean toward the back of the board down. So with the board in its normal facing up orientation, we are simply going to solder this. The connector is actually tilted down a little bit because I guess the connector is about 1.5 millimeters of space between the pins. It's a 2 millimeter pitch thing. And this is a 1.2 millimeter thick board. And the next size up is 1.6, at least for a normal standard production size. Okay, we are all done. Now we just need to test. Actually, it is a bit messy. I'm going to go ahead and do that alcohol bath. Give it an alcohol bath with compressed air, blowing it out, and then we'll test. By the way, the A500 Mini has only 3 USB ports, so with a keyboard, a mouse, a joystick, and a USB thumb drive, you are going to need a USB hub. I use this one, link in the description. So after a successful test, we need to proceed with the task of fitting everything into the case. The first order of business is to remove the USB port from the controller board and hardwire the board to the A500 Mini. And that was a simple matter of doing some continuity tests, making a diagram, and then doing some desoldering and resoldering. The connections for the caps lock LED and our 2 connectors for it. To match our connection on our keyboard controller board. The controller board has 4 LEDs on it. One is for USB power. The other 3 are for caps, scroll, and numlock functions. The second from the left is the caps lock, and I desoldered the LED and replaced it with a dual pin header. Starting with the ribbon cable connector, because clearances are tight, I have to cut off the top stress relief portion. Don't attempt to take it apart, just cut it. And when you cut it, use the Dremel. I went right through and sliced the ribbon cable when I used a knife. Here's a better look at the top part removed. And also, I needed to cut off the indexing tab. When fitting the whole thing together, a few of the support parts on the bottom of the case were just a little bit too long. And of course, there is the clearancing for the keyboard connector. Here is the inside of the case, fully assembled. Pay no mind to the folded cardboard spacer. So enough tweaking and fiddling resulted in a case that is very close to original. Something was bothering me, however. I felt I should block off the last USB port, since I had made it useless with my internal connection. So I went on Thingiverse and found something that I could use. So the caps lock light. How am I going to get the LED on the PCB to shine up through the key itself? The idea I have is to transmit the light to the top of the key using what they call end glow fiber optic filament. Despite the name, the material that this filament is made of is not truly fiber optic. I actually sell this in my eBay store, link in the description, mostly to model railroad enthusiasts, but I think it's the perfect application here. You can shine a light on one end and it will transmit to the other with very little attenuation, and you can blossom the end with heat to create a lens on the end to further the effect. When blossomed, the filament will be about the right diameter to fill the caps lock light spot on the key. I just need to make a small hole there, carefully increasing the size until it fits just right. Now it's time to remove the key from the assembly and line things up for drilling through our membrane. Once the job is done, you can see that even the ambient light from my work table shines through nicely. I think this is going to work. Now comes the extremely arduous task of removing the remainder of the keys and gluing them to the membrane. This will take me many tedious hours to complete, so let's skip to the end, shall we? So before we get to the actual demonstration, there's one small item I would like to tweak. The caps lock LED bleeds over a bit, and I think the fix for that is simple. So I just used a little bit of acrylic paint, which is usually nice and flexible when applied thinly, to coat around the caps lock key, but stay away from that little piece of filament. Go around it just to mask off that the caps lock indicator LED bleed. It bleeds over into the gaps between the keys, and since it was an easy fix, I went ahead and did this. And I can tell that it's going to work because if I go like this, you can see that you can't see around the caps lock key within the gaps, although you can see all the other keys through the gaps. So that should take care of that. Well, I knew this was going to happen because basically the keys, well, you'll always get a couple of keys falling off because it's hard to judge exactly where the contact patch is. These nubs on the membrane are smaller than the inside of the keys. So it might grab it on the top, it might grab it on the bottom. I've tried to do my best to guess where it would grab it, but undoubtedly you are going to experience a couple, two or three. In my case, I believe it was 3 keys. That's the third one that fell off. But quite expected, actually. So anyway. Okay, we're going to play Dark Side again to test the keyboard. For those who watched my last video, this was a sneak preview of what was going to happen in this video. Okay. As we can see, I can move us around. The mouse controls your gun, I guess. In conclusion, this build was definitely a challenge, perhaps the largest of which was the tedious repetition involved with 94 keys. I had to repeat several of the processes 94 times. Think of it as the equivalent of one of those challenging jigsaw puzzles. I give this a lukewarm rating of 7 out of 10 for usefulness, but a 10 out of 10 as a learning experience. I would only recommend this project to those very familiar with working with plastic and for those with good soldering skills. So if you're interested in this project, please check the description of this video for a complete bill of materials. I will be selling the PCBs in my eBay store as well as putting them up on PCBWay. There we go. Anyway, thanks for joining me again, friends, and we'll see you on the next one.
Thanks for watching.